Mechanical advantage is 0.8 something, 0.83, right? And
Yeah, sir.
VR is 1. So efficiency will be nothing but same, 0.83. If I multiply by 100, it will give you the percentage. So it will become into 100, that is equal to efficiency is 83% approximately, right? Is that okay? I don't know why a lot of people are calling me today. Just give me 1 second. So fine, we got this part here. It will be 83%. That is efficiency. Next question in it is uh, why the efficiency of the pulley is not 100%? This is a theoretical question. Why the efficiency is not 100%?
So because load is more than the effort is more than the load. No, wait. No, I'm lost.
Because there will be some amount of friction between the rope and this particular pulley also, right?
Yes, sir.
In practical,
So
in theoretical, in ideal situation, it would be what? In ideal situation, it would be say 100%, but it's not an ideal situation. So therefore, it will not be 100%. Some amount of energy is wasted in overcoming the friction between the rope and the pulley, right? And even the pulley which is hung to the ceiling, so there is a friction there also as well, right? So the answer is the extra. If it is 83% approximately, then where is that? 100% minus 83% is nothing but 17% is the waste of energy, and this energy has been used to overcome what? Overcome, can you tell me overcome what?
friction, friction,
Friction. So overcome,
friction.
okay. Oh, it stopped. Sometimes it stops. Anyway, the next question is going to be how much power was developed by the boy in raising the load? How much power was developed by raising the load? Can we calculate that?
Yes, sir.
I'm writing here power. Question is power developed by boy. How much? Power is what? Rate of doing work. So
Yes,
power
sir.
is work done upon time.
Time.
So what is the work done? Or we can say energy upon time also, right? Think I told you it has moved 5 meter in 10 seconds, right?
Yes, sir.
It has moved 5 meter in 10 seconds. So when he moved how much? 5 meter down, the load also moved 5 meter up. So effort is how much? 480. Am I right?
Yes, sir.
And displacement is how much? Effort means force. And what is the displacement? 5 meter. So the
5 meters. So it will become effort into displacement upon time.
and
So it will
upon
like
time was
240.
10 seconds. So how much is that? If you multiply this,
240.
so 5 8 are 40 and 5 4 are 20. 20 plus 4,
Sir, 20. Yes, sir.
240 watt.
Sorry, 240 watts, sir.
So that power is equal to how much? 240 watt.
Yes,
Clear?
sir.
Now the next part is of the question is uh, the boy has to apply an effort which is greater than the total load by load he is lifting. What is the justification for using the pulley? Why should he use pulley in that case? Why?
It's a single movable pulley tax, like it is generally used for changing the direction, sir.
So only, and yes, it will be the only in benefit of using it would be the change in direction, the convenient direction. We can use the word convenient direction.
So
Otherwise,
the effort applied by him will be less.
yeah, no, he is not effort applying his will be less. He is okay. He's putting an effort of 480 newtons to lift a weight of 400 newton only, which means he's putting more effort, though, I mean,
Yeah.
to lift a less weight, right? The reason why he is using a pulley, otherwise he could have pulled it directly. If he pulls it, he will have to bend down and lift it, right? So it is just a convenient direction that it is giving him. What is that? Convenient direction, right? So use of pulley helps in changing the direction of the applied force to a convenient direction, right? So I mean, one may also use his own weight as an effort also. I mean, convenient direction, he can himself be putting himself, okay, he will be hanging on that load, right, to lift that weight. Is that okay? So this is how it is good for him. Now, I'll be drawing another question here below that. So just 1 second. Let me draw it. The function of the second pulley is nothing but change in direction only. Now, then the next question is, if the free end C, so where is C? Let me mark it here. Free end C of the string. So this is C here. This is a free end, right? And people are putting the effort in this direction. That is E. If the free end C of the string moves through a distance x, it moves through a distance x. By what distance the load W will get raised? How much will it get raised? That's the next question in it.
So what, sir? Can you repeat the question?
Okay, if this string part has been moved down, okay, by x meter, right? How much will the load will go up? What will be the rise in the load part here? Anyone can answer? Any one of you can answer asking you.
So I think I got it. I don't know. I'll see for myself.
See, it is moving 1 meter down. This will move half meter up because you can see here. Can
Oh
you
yeah.
can you see? Right. If it moves
Yeah.
1 meter down, then it will only move half meter up. If it moves 2 meter down, it will only move 1 meter up. If it moves down x meter down, then it will move only x upon 2 meter up. Understood? And this is what happens when we take a pulley which is movable. Remember that. All of you are there or not?
Yes, sir. Yes, sir.
Okay. So that if the displacement in effort on arm is x meter, displacement
X by 2.
then the load arm will lift by x upon 2 meter. Is that okay? Now the next question is, what effort E has to be applied at C to just raise the load of 20 kgf. If this is 20 kgf, this load is 20 kgf, right? Then how much of effort would be required? We can neglect the weight of the pulley and the friction both. If we have to lift a weight of 20 kgf, how much of effort has to be applied?
What's that? How much of effort?
Yes, if the weight is 20 kgf, how much of effort will be has to be applied?
Sir, it'll be divided by 2 only.
What is the formula that we have?
Formula is
Okay, what is the velocity ratio in this case?
ratio, and that is lower.
What is the what is the what is
don't
the
know that. So that'll be 2, sir.
what is the formula for velocity ratio?
Load upon effort. Oh no, that's mechanical advantage. Displacement of effort upon displacement of load.
Okay, so that is displacement and effort is how much? X. And displacement in the load side is x upon 2. So velocity ratio is how much?
2, sir.
2.
Oh.
Right? What is the mechanical advantage? We do
So
not.
that is also 2.
Do we know it?
No, sir. We have to find effort. No, sir. So we don't know what mechanical advantage is.
Anyway, we don't need that. Do we need it?
No, sir. Sir, we don't require, sir.
We don't require. Then how do we find out what is the load in it? Remember, what is mechanical advantage? Mechanical advantage is it not 1 upon VR?
Yeah, sir.
Okay.
Yes, sir.
And what is mechanical advantage? Mechanical advantage is load upon
So load upon effort,
right, is equal to 1 upon 2,
VR. 2, sir.
right? What is the load in this case? You can write 1 upon VR, not a problem. What is the load here?
So load is 20 kgf.
20
Yes, sir.
kgf, and effort is supposed to be found out, right?
Yes.
Is equal to 1 upon 2.
1 upon 2.
So effort will be how much? 20 into 2,
So 20 into 2.
right? I think, are we right or we made some mistake, I guess?
That's so shouldn't it be upon 2? So we have to
Mechanical advantage is equal to 1 upon VR, am I right? Or is it VR only? Tell me. What is mechanical advantage?
so mechanical advantage is equal to VR, no, sir?
In this case, when we talk about the pulley, what is the mechanical advantage?
So for this pulley, it will be 2. Yes, sir. No, but we don't know. We have to find effort first.
No, I'm asking for this particular pulley here. Remember,
Yes, sir.
mechanical advantage, will it be equal to the velocity ratio?
No, sir.
The mechanical advantage is equal to velocity ratio.
Yes, I think yes, sir.
Yes, for the pulley it
So
would be,
it
right?
is equal, sir.
Okay, it has to be equal, not 1 upon a VR. So that is the mistake we did, right?
Yeah, sir.
Yeah.
So it will be equal to mechanical advantage
VR.
is equal to VR only. Fine for this one. So VR is how much? 2. So it will be 2 in this case. And if it is 2, then the effort will be how much? 20 divided by 2.
Yes, sir. Yeah, sir. Effort, yes, sir. 20 divided by 2.
And that is equal to how much? 10 kgf.
10 kg.
Remember,
Yes,
if I
sir,
put 10 kgf, I'm just lifting here 10 kgf to 1 meter down, and it will go up by only half meter, right? So that will be equal to twice the effort here. So yes, in this case it will be how much? 10 kgf is the effort he has to put. Clear?
Sir.
And this is another way of doing it here. We can also find in this manner. Here, what is the tension here? T. What is the tension here? T. And what is the tension here? T here. So is it not T plus T? 2T. Is that okay? And that is holding the weight. So 2T is holding the load, right?
Yes, sir.
And the tension because of the effort is how much? T only.
T. So T 2T upon T.
So load upon effort, right? That is what we get here as in the mechanical advantage also, right? So,
Yes, sir.
so energy would be required how much? That is equal to, okay, anyway, that is, we got 2T for the load and 1T for the effort. Clear? And say energy effort required will be equal to how much? T for 2T here. So we can equate it like this. T is required for 2T. Clear? So what
Yes,
is
sir.
what is the load here? Load is
20 kg.
2 into 20, right? No, sorry. Give me 1 second here. No, it has to be divided by 2 here, right? I think we are confusing over here. Fine. Nothing is such. Give me 1 second here. 1 second. One second here, just 1 second. Weight will be, the weight is giving you 2 tension, that is 2T. Effort is giving you just T, right? Effort is equal to, effort will be equal to the weight divided by 2, because load upon effort. Load upon effort is mechanical advantage. Anyway, it should be mechanical advantage. I don't know why. Anyway, the way we have done is correct. That is 10 kgf here. Clear? Now,
Yes, sir.
next question is, next question, just 1 second.
Of effort. Yeah, effort is and mechanical advantage.
Distance moved by the effort, first we have to calculate is, first we have to calculate distance moved by the effort.
Yes, sir.
Distance moved by effort. First one. So how to calculate this part?
So velocity ratio is equals to displacement of effort by displacement of load.
Distance moved by the effort here. So velocity ratio they have given you. So what is the formula for velocity ratio?
So dE by dl. Yes, sir. dE by dl.
So we can use distance moved by the effort upon distance moved by the load, right?
Yes, sir.
Distance,
So that is 80 meters, sir.
distance moved by effort, we can write E upon distance moved by load. Distance moved by effort is how much? 50. No, 50 is nothing, the distance here, right?
Sir, we have to find effort, sir.
Oh, okay, okay. Give me 1 second. We are not, okay. They have not given, they have not given that to you, right? They have only velocity ratio is given.
And even the displacement of
Okay, okay. Yeah,
load is
understood.
given.
Give me 1 second here. Now, so velocity ratio is given as 4. I will write 4 is equal to, and we have to find the effort,
D.
dE, right? Upon, and they have given the load, the displacement of the load. How much is that?
So
It is going up by
20 meters.
20 meters. So I will write 20 meter here. So we can
is
say
equal to
that is
20.
effort arm, displacement the effort arm is equal to 4 into 20, which is equal to 80 meter. Answer, right? Okay, next question is the work done by the effort. Work done by effort. What is the work done by the effort? So work done is nothing but force into displacement. We got the displacement here. This is the displacement, right? And what is the force? So work done is equal to force into displacement. Force is how much?
50 kgf.
50 kgf.
Yes, sir, 50 kgf.
And effort, displacement is 80 meter. So how much will that be?
80.
We need to convert this because kgf is there. We need to convert the meter into Newton. 50 kgf is how much?
So 50 into 10 newtons.
50
That
into
is
10. Why
500
10?
newtons.
Have I told you to use? If I don't tell you to use 10, you can't use it 10. You have to use 9.8. Yeah, so for the sake of simplicity, let us take that acceleration to gravity is 10. Now we can use 50 into 10. Right? And into 80. How much is that?
4,000. So 4,000 joules. 40,000.
40,000 or 40,000?
Yes,
1, 2, 3.
40,000.
40,000 joules.
Yes.
And that's the work done. Next question, third question is, the efficiency, the mechanical advantage, MA we have to find. MA is equal to?
3 load upon effort 150 upon 15 and we come 3.
So load upon effort, we can find it out. What is a load? 150.
So you already get.
And effort is 50. So that will give you 3 directly. Right?
Yes, sir.
Now, what is the next question? That is the efficiency of the pulley system. We have to find efficiency. That fourth question is efficiency. What is efficiency? Means eta is we have to find. Eta is nothing but?
So mechanical advantage by velocity ratio into 100%.
So mechanical advantage by velocity ratio into 100. And that will give you percentage, right? So that is equal to how much?
So the mechanical advantage is 3 and velocity ratio is 4.
Mechanical is 3.
4 into 100.
We got the velocity ratio is how much?
4, sir.
4 into 100. That will give you 75%, right?
Wait, sir, 1 second.
75% will come 75%. 3 upon 4, 3/4.
Yes, sir. Yes, sir.
Okay.
75.
Next question is the total number of pulley and the number of the total number of pulleys and the number of pulleys to in each block. We have to find. What is the formula for it?
What's that?
We have to find the total number of pulleys and the number of pulleys in each block.
Oh, okay. Sir, in the question the given the pulleys is equals to number of pulleys as 4.
They have already given 4.
Yeah.
They have given the velocity ratio of pulley system with a velocity ratio of 4 is used to lift a load of 150 kgf. Right? They have not given the number.
Velocity ratio is equal to the number of pulleys, so therefore it's 4.
So the number of pulley is always equal to
PR and MA.
VR, right? And that is also equal to MA. So that is VR is it VR upon MA? Tell me.
What's no, sir.
Then
Number of pulleys is equal to.
so is the number of pulleys VR only?
Yes, sir.
Yes. So that will be 4.
Yeah, sir. 4.
Fine. And the number of pulleys 4. The number of blocks is how much? Number of pulley in one block will be how much? Number of pulley
Sir.
in
4.
one block. How many blocks are there?
So total blocks, what's it?
How many blocks would be there?
So total is it 4, no, sir?
Total number of say pulley is 4. Understood? That is equal to velocity ratio, right? But how would you find the number of blocks in it?
So is it like the block and tackle system of a pulley?
Yeah.
Like 2 up and 2 down.
Hmm.
So total is 4. Yeah,
So
four, I
in
think
each
four.
block that will be 2.
So number of block is 2. So it will be 4. 4 divided by 2 will be how much? 2 pulley in each block.
Yes, sir.
Okay. Understood? Right. I think you need to work
So
on that.
then, if the number of pulley is 5, then how many will be the, like, what is the number of the pulley in one block?
That is a question mark coming up here. How do we know that it will be 2 blocks?
So,
How do we know that?
so
Any idea?